All right, this is video number 7. Okay, this is circular motion. Why do things go in a circle? They don't really want to go in a circle. An object in motion tends to stay in motion, move in a straight line. Remember that cat that was on the ceiling fan? Going around and around and around? Well, that cat really wanted to go in a straight line. And finally, when its claws let go, it did go in a straight line, which was hilarious, by the way. I love cats to a certain extent, but I'm more of a dog person. So, if you have a circular motion, pretty good circle, what's going to happen is if your kitty cat is over here, okay, and it's going around and around on the ceiling fan, it's trying to go, it's terrible. Bad, Mr. Wilson. It's trying to go in a straight line. That's the way its velocity or inertia, you know, we talked about an object in motion tends to go in a straight line. That's the way it wants to take it. However, if there's a force, which by the way, Faith Hill has all wrong, right? Centrifugal, centripetal Faith Hill. If you're watching this video, I'm not available, I'm married. It's too bad for you. But centripetal force is a center-seeking force. Centrifugal forces, which you like to sing about, don't exist. Have a nice day. So, this is your centripetal force or centripetal acceleration. And if you look on your reference tables, you find that it's equal to v squared over r. If you take the velocity or speed, velocity and speed, by the way, are the same, except in almost all cases, except velocity has direction to it. So the number is the same. So if you look at velocity squared divided by radius, that's going to give you acceleration, meters per second, and then you square it, meters for your radius, and then meters per second squared. What ends up happening here is they give you this equation. Okay, F equals ma, you knew that already. But then we said you can combine those two into one that used to be on the reference tables that I would recommend you memorize right there. So, let's talk about graphs. If I talk about graphs, if I have AC versus R, what's that graph look like? Was that Stanley? Yes, that's correct, Stanley. Mr. Stanley got this right. Moose is going to do the next one. Centripetal force versus acceleration, centripetal acceleration. Moose? Yes, nice job, Moose. It's going to be like this. And then if we had centripetal force versus radius, that would be like that. What other ones do I have on here? Centripetal, I have that one. How about in centripetal acceleration versus V? Well, because they're directly related and there's a squared, it's going to be up like that. So remember, this is indirectly related, like that. Indirectly, same thing here. You can go like that and like that. But these two are directly related and there's no squared. So if I had FC versus V, it would also be like this graph right here. Now, what is force measured in? Force, always, force, is newtons. I think even Faith Hill knows that. That is the end of circular motion. Thank you.